All right, let me get, there's Lucy. Hi, Lucy. Well, I gotta put the lens on too, so we can see more people.
Hello.
There you go.
Oh. Yeah, now.
Now you're in the video.
Oh,
It's mirror image though. It's weird, right? Because it's flipped.
yeah. I'm still in the exact same spot.
You are. This is kind of dirty. It should be a little better, right?
Better.
A little bit better. Not a whole ton, but a little bit better.
Is it for lap 12?
Today is 13. Today's lesson 13.
Like the demonic.
The mnemonic was for lab 11.
11?
Yeah, remember you did the balance, you practiced balancing equations.
Do you get to turn it in?
Yeah, well, you already turned it in. That's what you did. That's what you showed me this morning, right?
The mnemonic is for lab 11?
Yeah, because remember lesson 11 was virtual because I was out of town.
Oh, yeah.
So the lab was virtual and you had to do the balancing equations.
Yeah, I did the balancing equations.
Yeah, so then that's what the
I got
mnemonic was.
proof. I thought you weren't doing this, so I got to prove that I got everything in one track.
Oh, look at you. All right, you wrote them down.
I took a screenshot to make sure I didn't cheat, and I got it.
Great job.
100%.
Great job. I love it. Very good. We're gonna practice more balancing today, and I'm gonna let you guys balance with marshmallows.
This thing, for the last question, it was totally easy. It's like 2 FE, and then there's 1 FE on the side, and it's like 2 FE, 1 FE, not equal. Just add 2.
Yeah, you're all good.
I should do it again next time.
Oh yeah. Well, today you're gonna get to use the marshmallows today. Practice the balancing with the marshmallows. Yeah.
Cold.
Are you cold?
Hi.
Hello. How are you?
I think I left my marshmallow here.
Oh, that's okay. I've got new ones for everybody today.
Yep.
Can practice some more. Not these. These are the eggs. We'll practice in a little bit.
Good. Also, where is your little sister? Roman's Canada. Oh. Who is this? He's.
Oh, he's here. You can take these and whatever. Go ahead and add her. We're gonna do it. Don't open them yet, though. We'll do them towards the end of the lesson. So don't open them just yet.
It's my back regular spot.
Oh yeah.
Instead of being in the camera.
Yeah, you're fine. You're all good.
My old regular spot.
The regular spot. Good morning. Just hang on to your marshmallows.
Can you take this thing?
Do what? Yeah, you can. Well, you won't need it yet. It's for later.
We also
Want to make sure everybody has. What we do is we'll use this. You'll put this in your lap, and we can practice balancing.
Do I have to turn my lesson 13 the tries needed paper?
Yeah, if you have it, go ahead.
Okay.
If you don't, it's not gonna do it.
Can I also turn in my the real like the. You have a stapler?
Yeah, right here.
I'll skin.
All right. Well, hello, everyone. Oh, you got that? Okay, cool. If you did that last page with your number of tries, you can put it in the folder over there. How was everyone's weekend?
Good.
Is it good? I got Mr. Burt out safely on Sunday night. He's back home now. He had a good time. We actually went to Stone Mountain on Friday?
Wait, you went to Stone Mountain? I went to Stone Mountain.
I haven't been there in a long. I haven't been there in a long time, but it was fun.
There was this kind of lift which takes you,
Yeah,
like,
we
off.
did that, and he'd never been in a gondola before, he said,
I
so
was like
he has
so
a-
scared.
he has a little mobility scooter that he treats like a car, like he drives it on the road, which you're not supposed to do. You know, you can't tell him not to, so. But he drove it into the little gondola and we went up to the top of the mountain and he got a good look at things and then we drove back down and it was fun. So, hey, whatever.
Boom, boom.
Yeah. Oh, yeah. He has two of them. He has one that he keeps in his apartment at his assisted living and then he has another one that he keeps at his shop. And he quite literally drives them down the main roads of the city he lives in as if it's a car. He even put side view mirrors on the one at the shop so that he can see behind him when it's silly. But you know, you can't tell an old guy who's spent his entire life working on cars and driving that he can't drive at all anymore. So we've got something to drive. Yes, ma'am.
Speaking of illegal, when we're going to Walmart or any place where we have to take our load inside, Papa puts a service bandana on a service dog bandana on our load so they can sneak him in so he doesn't die in the car.
Oh my goodness. Oh goodness. All right. Well, while we're admitting things. All righty. Let's move on and start our lesson today. So this is more balancing chemical equation and it's a review because what we needed is one more lesson for the lab rats class before we end unit 5. So because we needed one more lesson, you guys get a lesson 2 review. All right, just extra review. So let's look and see. What have we got today? So today we are talking a little more about chemical equation. So a chemical equation shows a reaction using symbols instead of words, right? So in lab, we've done a couple chemical reactions so far. And if you had to write them out, you would write them out as a chemical equation. But if you had to speak about it, you would describe it using words. Today, we're going to be taking sodium carbonate and mixing it with strontium chloride, and it's going to produce sodium chloride and strontium carbonate. So that's how you would say it with words instead of with a chemical equation. So what does a chemical equation contain? Let's remind ourselves. It's a reactant plus a reactant, sometimes an extra one in there, but it's going to yield a product. So the reactants are going to be on what side?
The left side.
On the left side, and then the products are on the right. And what's the word we use for the arrow? What's the arrow mean? What's the word?
Yield.
Yield. Very good, guys. Yield. Okay. So reactant plus reactant yields product plus product, or sometimes just product, or sometimes it's reactant plus react. You know, we can do all kinds of different things. We can break things down, but in general. So we have subscripts and coefficients. So what do we call the little numbers? Who can tell me? Are those subscripts or coefficients, Emerson? Those are subscripts. What does sub mean? Below. Very good. What does script mean? Anybody know? Do you know?
It's like right.
Right. Very good. Okay. So sub means below, script means right. So if you're writing it below, it's a subscript. There it is. That's where we use those. I tell you all the time, now we use a lot of Latin and Greek roots in science, and it's really helpful to know what they mean. Here's a good one for you. Do you know what a contractor does? Like for construction, do you know what a contractor is?
A contract is like when you sign.
No, not a contract, a contractor. So a contractor is somebody that you have signed a contract with. So it's basically somebody who, like, say you wanna completely redo your bathroom. You might hire a contractor in. Do you know what a subcontractor is? Do you know?
Below the contract.
Yeah, what do you know what might a subcontractor do? Do you know?
They might supervise the contractor.
Good guess. What do you think?
You might work under the contract.
Yeah, they work under the contractor, and so say you own a company and your job is to redo bathrooms. And that you're a contractor, your subcontractor might do something like maybe you have a specialist in tile. And he comes out and just does the tile, doesn't do the plumbing, he doesn't do the drywall, he just does the tile, he's a subcontractor, right? And then script. There's another word that has script in it. Can you think of the
The
word?
scripts that you do in movies.
Yeah,
and all
scripts
that
for
stuff.
movies. Can you think of a word that has script in it? What do you think?
I have a word like prescribe, but I don't.
Yeah, there you go. That's the same word. Prescribe or prescription is you write for something you want someone to take.
Subscribe.
Subscript is the one we're talking about. Yep, there's another word with script in it. Very good. All right, so what are these ones in the front called? The big ones. What do you think? Oh, Everly. What are those ones in the front called? These are the subscripts, and these guys, like 3, 2, what are they? Subscripts, or does she know? It's right here at the top. Coefficients, that a girl. Okay, coefficients. All right. So subscripts and coefficients. So subscripts indicate the number of atoms of each element present in a molecule or a formula unit. What's the difference between molecules and formula units? Formula units
Or the.
have what kind of bond, Annabelle? Do you know?
Chemical.
They're chemical, but so are molecules.
Ionic.
Ionic, right? Ionic bonds are formula units. Very good. And molecules have what kind of bonds?
A molecular bond.
Molecular bonds, or what's the other word we use?
Covalent.
Okay, covalent. Yep. All right, there you go. So, and the coefficients show the relative number of each substance. So, how many in this example here? This is the same on both sides. Do you agree it's the same chemical equation on both in both pictures here?
Yeah.
So looking at it, in the reactant side, listen carefully, how many units or molecules of oxygen do we have? Units or molecules of oxygen? What do you think, Annabelle?
5.
Not 5. Good guess though. What do you think?
It's 6 because there's 2 oxygen and 2 times 3.
Well, almost. So how many units or molecules of
3.
oxygen? 3, because the coefficient says there are 3, but how many atoms of oxygen are in each molecule?
2.
2. So how many atoms of oxygen do we have?
6.
6. Right. So, okay. If you see it says 3 O2. That means you have O2, that's 2 oxygen atoms paired together. They're friends, right? They're holding hands. They're not letting go. And then you have 3 of those. So you have 3 sets or 3 couples, right? 3 sets. All right. How to balance chemical equations. So you've seen this before, so this isn't completely new. So first things first, I want you to take one of these. I want you to take one of these right here, and I want you to fold the paper back because you're not going to use the paper yet. And yes, here, I'm going to give you a marker. So there you go. Oh, you already have one? Cool. So fold the paper back because you're going to use the paper when we do the marshmallows in a minute. Fold the paper back. And here you go. Here's your dry erase marker. Here you go. All right. Do everybody have one? You have one. Here you go. You need this one? Hold that. Keep that paper back. You need a marker. Yeah, you can do the opposite side like that too. That's just fun. Just be careful when you flip it over, you don't get it all over your pants. All right. So the first thing we're going to do, this is the equation we're going to work with. All right. So we're going to practice. And the first thing we're going to do is draw our bracket. And it looks like that. What?
I watched my older brother's video with him.
Yeah.
And that's the exact same thing.
Yeah, it is. It's the exact same
And I
thing.
also did it with him.
Good. You'll be good to go. This is a good video to help you this is a good one to use as an example. That's why we're doing it again. So everybody draw your bracket first. Get that nice bracket drawn in there. Yeah, you can write that equation on top if you want. So make sure everybody gets that done. I'm gonna write that equation at the top. Got the equation? All right, let's read this in words instead of as symbols. Who thinks they can tell me what it says in words? Do you know?
There is 2 iron, 2 oxygen, plus 3 oxygen plus 1 carbon. that's the reactant, and then the product is 1 iron plus 2 coal,
Ah, yeah.
one carbon plus 2
Right.
oxygen.
So that would be breaking it down into the atoms. So if we want to read it as the compounds that are there, does anybody want to guess what Fe2O3 might be? Do you know what it is? So it's iron oxide. Iron oxide plus carbon yields iron, and what's that last one?
Carbon dioxide.
Carbon dioxide. Very good. All right, so that's what we're getting at. All right, we see where we're going? All right, so the next thing we're going to do is we're going to place the reactants and the products on opposite sides of that bar. So it's going to look like this. So everybody take a second and do that. There you go. All right. Everybody about got that? Excellent. All right. What's the next step? Who knows the next step? Do you know? What is it?
This the metals, non-metals, yeah, and hydrogen and oxygen.
Right. The metals, non-metals, except for hydrogen and oxygen, and then hydrogen and oxygen, and list them in that order. But you got to write what you're writing is the total number of atoms. So you're going to do metals, non-metals, except for hydrogen and oxygen, then hydrogen, then oxygen. And you're going to write them vertically like this. All right. Why did we write 2 next to iron? Because there's two irons. We see it, Fe2.
There's 1 C and there's 3.
1 C. Why did we separate the O from the Fe?
Because it's different.
Because it's going to get broken up in the reaction, and we have to write it as metals, non-metals, hydrogen, and then oxygen. So we have Fe, there's 2 of those. Carbon, there's only 1. And then oxygen, there's 3. Everybody agree? Does that make sense?
Yes.
All right, so then we're going to write our products the same way. All right, so on the other side, we've only got 1 iron, 1 carbon, and then 2 oxygen. All right, now, yep, get it done. Take your time.
Good.
All right, so what's next? So here's what you have to remember. You can't change the subscripts when you're balancing, but you can change coefficients. Remember, that's the big number in the front, not the little number underneath. If you add a coefficient anywhere, you have to change the number of all the elements that it will alter. So it's kind of like a game. You can think of it like a logic game. Don't think of it like math, because the math is very basic math. It's just very basic, like addition, subtraction, division, multiplication. Little math, like 2nd, 3rd grade math. So think of it like a logic game, all right? So we're going to look here, and we're going to start with our metals, right? That's what we're going to do first. Irons across the top. We have 2 iron here, but 1 iron here. So we're going to cross out the 1.
Add 2 in front of
Because what do we need to make this 1? What is
2?
Why do we need to make it into a 2? Because there's a 2 over here, right? So we're going to make it into a 2. Now that we've done that, what do we have to do now? We have to go back to the top over the bar, and we have to say, okay, we have to show that there are now 2 iron. We can't do it as a subscript, so we have to do it as a coefficient. So it goes right there in front of the Fe. 2 Fe. Everybody see it?
Yeah.
All right, 2 iron. Good. So now we're going to move on to our next element, metals, non-metals, hydrogen, oxygen. And we're going to look carbon. We got 1 carbon. How many carbon do we have over here?
1.
All right, so we know this was good because we have 2 and 2. We agree? 2, 2, 2, 2. All right, carbon, carbon, check, check. All right, now we go to oxygen. We have 3 here and 2 here. Uh-oh, they're not the same. 3 and 2 are not the same. So when you get something like this, the easiest way to remember is usually if you multiply the numbers together, that's the number you're going to want to put in the top.
Or you
So
do the LCM.
Yeah,
common
the
multiple.
least common multiple, which is usually multiplying them together most of the time, but not always. Not always, but a lot of the time it'll work for this purpose, okay? So for anything you're gonna do in this class, yes, but you are looking for a least common multiple, you're correct. So if we have 2 here and we have 3 here, what are we gonna do so that we can get the same at the top? Emerson, what do you think? You put a 3 here. So this guy has to become times 3. So it's going to be 6. All right. So we do that. Now what do we do next? We're going to have to take this and put a 3 here because we multiplied by 3. 3 goes in the front. So 3 times there's 2 oxygen. 3 times 2 oxygen is 6, right? All right. Now over here, we have this 3. How do we get 3 to become 6, Emerson?
2.
You multiply it by 2. Good job. So we're going to multiply that by 2 and it's going to be 6. So this oxygen, remember, we cannot change the subscript, right? So we have to put the 2 all the way over here in front of this compound. So we're going to put that 2 there. Now we have 2 sets of O3, which means we have 6.
But we have
Agreed?
one problem.
What's our problem?
We have 4 iron.
Oh, no. There you go. You've got it. So what you have to do is after you've gone all the way through, check, 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 you have to go back to the beginning again because now you've changed things, right? You added coefficients, you changed things. So we go back to the beginning. So after balancing your first non-metal, go check to see that your metals are still balanced. And if they aren't, you just repeat that step again. So let's look here. Iron 2 is what we had. Do we still have 2 iron?
No.
No, how many do we have? We have 4 iron. All right, now how many do we have over here? 2s, that's a problem. What do we have to do? Multiply which side, Emerson? You change this 2 into a 4, which means we have to change what? This coefficient to a 4. Very good. So now we have 4, 4. Yep, that's good. Now, how many carbon do we have? We have 1 carbon on this side. How many carbon do we have over here? 3, right? 3 carbon. So what do we have to do? We have to make sure that we see this. This is now 3. So what do we have to do with the other side, Emerson? Put a 3 there. So now we got a 3. Now we have 3 carbon and 3 carbon. Do we all agree?
Yeah.
Yep, check. That's good. Let's look back at the oxygen. We have 6. We're saying, do we have 6? 2 times 3? Yep. How about over here? 6. 3 times 2. Do we agree? Yep. And you're done. Look at that. You did it. There you go. So there is your balanced equation. That's what it looks like. That's what everybody should have. All right, so there's an extra credit opportunity. It says today, but actually I opened it a week early and I mentioned it in your weekly email. But if you go into your Teacher Ease, you'll see an extra credit assignment in there. And it is a virtual escape room where you are going to balance equations in a virtual escape room.
I did 2 BCCE 7 and I'm stuck at it.
Uh-oh, okay, keep
I
trying.
did-
So what you do?
I did a real escape room once and after when we were finished.
Yeah.
I felt like I was about to go insane.
I bet. Miss Lucy?
Are the teenagers gonna be using these boards?
We have plenty, but yeah, they'll be using them too. They can erase if you're drawing something. So when you do this assignment, if you choose to, you don't have to, but if you do this assignment, there's a start code. And it's this right here. You have to put it in exactly like that with the weird capital letters in the middle. Okay. And you put it in like that. It's in the assignment. You'll see it. So you copy and you paste that in, and then you work your way through the escape room. And what you do is at the end, you'll get a page that says success. If you've done it correctly, screen capture that page. And then you upload it to the assignment. You upload that picture and then I'll give you up to 2 points on your midterm. Okay?
Really?
Yeah.
Is it till BCCE 10?
Is it what?
How much assignments are there?
How many assignments?
Yeah, how many like? escape room stuff.
Just the one, I don't remember how many rooms you have to go through. I don't remember.
BC's, I'm stuck in BCC 7.
Okay, I don't remember. I'd have to go back and look. I looked at it a little bit ago. I don't remember how many rooms you had to go through to get out. You have to open door after door, right? Basically. But it's a lot of fun. All right, so now we're gonna practice with the marshmallows. So a couple of you left kind of early last week when lab finished and you didn't stay for the marshmallows. So who has practiced with marshmallows so far? Anybody? Did anybody get to practice with them? Yeah, I didn't think so. All right, so we're gonna practice with them now. So what I want you to do is I want you to take your marshmallows and take your clipboard and put your paper down like this, because I don't want you to put your marshmallows on your dry erase board, because that's gross. Okay, Lucy, you have your marshmallows? All right, those are extras. All right, so I think everybody's got them.
I want to eat them.
Oh, well, when we're done. All right, so we're gonna practice now with these. You can put it in your lap, or you can get around the table, or if you want to sit crisscross applesauce, you can do that too. So what we're gonna do, y'all already watched this video. We're gonna, oh, did you lose? What'd you lose, Everly? She's looking for something. All right, so here we go. Excuse me, my voice is going out this morning. Yeah, okay. So what we're gonna do is what we just did, except instead of using numbers that you write, because numbers that you write are symbols, right? It's a type of symbol. So what we're gonna do is we're gonna use some actual manipulative. You're gonna use the marshmallows as your atoms, and it will help you see what you're doing as opposed to just working it out. So we're gonna work through it a little bit at a time. And as we work through it, I'll like pause and let me take that remote just in case the volume isn't high enough. I don't know where the volume will be. We shall see.
We probably will. Beginning.
Maybe, we'll see. So I'll pause as we go, so you have time to keep up. All right.
Now, we're gonna go on found some marshmallows like we did earlier today. If you'd like to use glue for your marshmallows.
Some
corn
people
syrup
like to
works well.
glue them, but you
Today I
don't.
had vanilla flavored corn syrup. I just happened upon it, didn't know it existed, and it sounded pretty cool to me. And if you don't have colored marshmallows, that's fine. Try Skittles, M&Ms.
I'm gonna pause it for 1 second and see if it helps. It's kind of blurry. I don't know. See if I can back out of here. Sometimes I can make it less blurry if I, okay, let's try it again. There we go.
Final equation.
I got the smell.
There we go.
Now, if we're gonna go up, sounded pretty cool to me. And if you don't have colored marshmallows, that's fine. Try Skittles, M&Ms, Fruit Loops, coins, colored beads, or even colored paper hole puncher dots. There's lots of things you can use.
Okay, here
So
we
we
go.
only have 4 colors of marshmallows. So what we did is we kind of changed what color represented what element, but we did try and repeat, if we repeated an element, we repeated that color.
So we're gonna try and keep green for oxygen, and we're gonna try and keep orange for carbon. Now we may need to swap it out depending on what elements we're working with. But for this one, all of our oxygen is gonna be green, and our carbon is gonna be orange, our sulfur will be yellow, which makes sense because sulfur is yellow. And then we're not gonna use hydrogen in this one, so we don't need to worry about it. You got squish. Do you need a new one?
Yes, and orange.
What happened? Can you wash it?
No.
Here. I'll trade you that. No good. All right, there we go. All right. So here we go.
It's like orange.
So let's see, what do we need to have out?
So here's how we're gonna set this up. We have 3 oxygen, or oxygens are green, but we have 3 pairs of oxygen. So we have 1, 2, and 3 pairs.
All right, 3 pairs of oxygen. So take your marshmallows. You're fine, just take a second. 3 pairs. So that's 1, 2, 1, 2, 1, 2. There you go. So Emerson has her pairs like side by side, right? There you go. 1, 2, 1, 2. Perfect. There you go. And sometimes you can even stack them right on top of each other too. So you got 1, 2, 1, 2.
Or green. We have 6.
You're good for right now. I'll get you more if you need more. You may need, there should be enough in every one of these. Like if you haven't eaten any, there should be like 12 of each color, which is enough for all but like the last one of these where you kind of run out. Okay. So everybody has their 3 pairs, right? Everly, you got them, 3 pairs? All right. So the next thing,
And if you count them, you'll see there are 6.
6 total, right?
And we have a carbon with 2 sulfur. There's a carbon and 2 sulfur.
All right, so do your carbon and your 2 sulfur.
So
Mm-hmm. There you go. Okay, so you have 3 pairs of oxygen and a carbon with 2 sulfur. Everybody got that? And on the other side,
And we have a carbon and 2 oxygen. There's a carbon and 2 oxygen. And
do your carbon and 2 oxygen. What is that?
what was it?
It's just Yusuf like squishing his water bottle.
And I see the Lego dude you made.
Yep. And then what are we gonna do next?
over here, we have 2 sulfurs with 2 oxygen. So here's 1 sulfur with 2 oxygen. There's the second sulfur with 2 oxygen.
All right, so your setup should look like that. Let everybody get their setup like that.
2 sulfur and
There's a sulfur with 2 oxygen and then a sulfur with 2 oxygen.
this is making me hungry.
Well, you can eat them at the end or you can take them home and practice with them and then eat them later.
Eat lunch first before I can have it.
Yeah, good girl. Good girl.
Yeah.
She's smart. Everybody have that? All right, so now let's look at what we're gonna do.
So now what we're gonna do is count. 2, 4, 6. 2, 4, 6. Okay, good. Now, if you're gonna do it the same pattern as before, so you can start with your metals and then you say the same thing here. You say 2 sulfur and 2 sulfur. Okay, 1 carbon, and do oxygen last. Fine. 1, 2, 3 times 2 is 6. 1, 2, 3 times 2. And you'll see it's the same amount and it's balanced. And when it's balanced, you're happy.
So that's already balanced. You didn't have to do anything.
So the calcium, chlorine, it look like this.
2 chlorine. So this time our chlorine is gonna be green. Okay,
Well, yeah, I know. The only one, when I was like, chlorine is an element, I was surprised because it's normally it's the stuff you find in the pool leaf.
yep, it is. It's an element. So get your 2 chlorine. Everybody have 2 chlorine? And then we're gonna have sodium bromide.
1 sodium with 1 bromine.
There you go. 1 sodium, 1 bromine. And they're together.
So hungry.
So our sodium's gonna be orange and our bromine's gonna be pink this time.
Now there's
And then on the other side, somebody tell me, what is 2 NaCl gonna look like? Somebody build it. Build it. Go ahead and build it before I put it out. Build it with your marshmallows. Let's see. Everybody give it a try. 2 sodium chloride.
this.
Yeah, so what's a sodium chloride? A sodium chloride is a orange plus a green. And an orange plus a green. Yeah, you may want to separate them a little this way. Yes, so that you see that those 2 are together, right? There you go. So you got one side. Now what goes here? Sodium and a chloride. What color is sodium? So
Yeah.
orange and green. And then another orange and green. There you go. You got it. You got it. You got it. You got it. Perfect. All right. And then what's that last one gonna look like, do you think?
On the other side of the bottle.
There you go, like
have
2
sodium
peas stuck
potassium.
together.
We'll get sodium and potassium because that's what our coefficient.
Not
is.
calcium, chlorine. I said
A pair of bromine
calcium.
over here. So what do? Let's start then with a metal. I can pick sodium if you want. You got 1 here, you got 2, 3. Move through this chlorine here. There's lots of ways. As long as we're getting the numbers straight, that's what matters. So there's our sodium. We did another one over here, didn't we? Because we had 1, we had 2. So we popped this guy down here. All right, cool. But if we're gonna do that, remember that we're gonna have to be making that as a coefficient. And that's gonna change some things. So that means if he is paired up as a molecule, you have to bring down the bromine too, add another bromine too. So if you have 1 of these, you have to make a second of these, okay? That's 2. There we
So
go.
there's your coefficient,
And let's
right?
turn
That's where your
down.
coefficient comes from.
2 and 2, that looks good.
Wait, I haven't
2,
written
1,
the other
2,
stuff
1,
down
2.
yet.
It's balanced.
There you go. Yeah, it is. It is balanced.
Down.
You don't have to write it if you don't want to. We're just working with the marshmallows, but you can write if you want. But do we agree that that's balanced?
Yep.
Let's
Yep.
see. Metal, sodium, two,
Two,
two.
Two.
Yeah, non-metals, chlorine, chlorine, yep, okay, looks good to me, look good to you? All right, we are getting somewhere.
1, 2, hey, check it out. Very good. Moving on.
Oh, okay, I'm gonna let's see if you can build this yourself. I'll give you a minute, see if you can build it all out. Fe2O3 plus 3CO.
I don't think I can.
This is the one we did a few minutes ago with numbers, remember? It's the same one, and now we're gonna do it with marshmallows.
So it's 2 iron.
3 oxygen, they're all together.
All together.
Yep,
Carbon dioxide.
carbon monoxide.
We see.
I think this is the same one you did. Maybe it's not, but it's similar. If it's not, yeah. There you go.
Using a lot of oxygen.
Yeah. Actually, I think this one's different than the one you did before, but it's very similar. There you go. I just cleaned the floors.
The sodium chloride have.
Marshmallows are rolling away.
Let's see.
The green ones are the squishiest.
Yeah, are they?
I got them met them in 1 iron. Done. One.
Done? Everybody think they got it set up so far?
I'm done.
Okay, give everybody just a second, see if we're set up.
Push the green.
Okay, let's look through and see what we did.
2 iron and 3 oxygen. We have 3 carbon monoxide. 1, 2, and 3 carbon monoxides. And here we have 3 carbon dioxides. We have carbon monoxide, now we're gonna have carbon dioxide. There's 1, 2, 3, and 1 little lonely iron by himself. There he is.
There you go. Does everybody have right about that? Now look what you got. Good job. Very good. All right, so now let's have a look. Metals. How about the iron? What do we have? We have 2 here and we have 1 here. So what are we gonna do?
Add a coefficient in Fe.
Yeah, there's gonna have to be what here?
2.
2, because we're gonna have to add it. So let's do it.
So, how do we deal with this? Well, let's see. We add another iron, since we're starting with a metal here. We now have 2 iron here and 2 iron over here. That looks good. So that has to become a coefficient of 2. All right, great. Now let's see how many carbon do we have? 1, 2, 3. All right, 1, 2, 3. Good. And how many oxygen do we have? 1, 2, 3. 1, 2, 3. So that's 6. And then 2, 4, 6. So that would tell us we are balanced.
Good job. You did it.
How about this one? Carbon and
All right, I'll give you a second to set this one up.
The greens are definitely the squishiest. Carbon's orange. 1 carbon plus each hydrogen.
Y'all are doing really well. I guarantee you there are not a whole bunch of kids y'all's age that have any idea how to do this. So good for you. This is big stuff, really. Y'all are doing really, really well.
Can we just CO and back to sneeze?
We know
Not
what,
coming out though.
we know what water is.
Oh,
I'm just
if
kidding.
you need to and you can't, you know, the trick is to look at bright light, right? That usually does it. Like, go put your face in the light puddle over there coming through the window. That'll do it every time. Oh no, that usually works for me. Got it? Okay, so we have a carbon, and then what's this?
What's wrong?
What's this right here? Water. What's this right here?
Big whiff of dust.
Carbon monoxide and hydrogen gas. So carbon plus water yields carbon monoxide and hydrogen gas. All right, so this is what our setup should look like.
is your carbon monoxide and hydrogen gas. So you have a carbon and a water
Water.
and a carbon monoxide and hydrogen gas.
Everybody have that?
I got it correct.
Everybody got that? All right. So what are we gonna start with?
Already done.
Metals. Gonna be carbon, right? Carbon, carbon. And then hydrogen, two, and then oxygen. What do we know here? Hey,
Carbon, one.
Wait, the yellow, we have to do
Hydrogen,
some.
two.
hang on.
And oxygen, one. What does that tell us? They're balanced. Excellent. Next one. All right, this is. looks
This
like
is
a
one
little
where you
more
might
complicated,
run out of
But
a color.
you're just gonna need a lot of markers.
Yeah, you're just gonna need a lot of marshmallows. You might actually need to like write the letter, like G for green or whatever, or you might need to write the chemical symbol out because you may run out of marshmallows. So
It's
two,
almost last time.
so we need C2H6. So you're gonna need half of your pink ones are going in here,
Carbon.
but you're gonna need it twice. So all of your pink ones are gonna be on one side here. You're gonna run out. That's okay though. You can write the letters on the other side.
So we have 4 carbon. Geez, 6 hydrogen?
But it's actually how many? 12, right? Because there's a 2 in front.
6 plus.
So you will run out of marshmallows. You're gonna have to use a letter or something. Use a symbol.
CO2.
You can write an H on the other side.
10, 11, I only have.
You should have 12 in there. I think one may have rolled away or something. So let's watch it.
So 2
Everybody's gonna run out.
C's and 6 H's, but 2 sets of them. So there's one
I
set,
just picked pink.
2 carbon, 6 hydrogen, and
Oh.
the second set.
There's your second
And then
set.
over here, for oxygen, 2 gas, there you go. Carbon dioxide again, one of them, and 6 water. So that's 2 hydrogens and 1 oxygen.
So you have 6 oxygen
Sorry,
on
didn't
each
stick
side?
around.
I like
2
12.
hydrogens
Yeah, 12 on each side.
times
12.
6.
Sorry,
So
So that's how it would look.
Alright,
You had all the marshmallows.
what are we gonna do? We have 12.
So we have 12 hydrogen over here, but let's look at our carbon first. Carbon, how many carbon do we have? We have 1, 2, 3, 4, and then how many here?
5.
1 over here. So what do we have to do here?
Make it into a 4.
Yeah, this is gonna have to be a 4, and when this becomes a 4, how many oxygen are we gonna have? 8 over here, but how many are over here?
2.
Oh, but it's not just gonna be 8 because look, 1, 2, 3, 4, 5,
14.
6. Oh, 14. How do we make this number? How do we show 14 here? What has
7.
7? Very good. So watch it happen.
We have 1, 2, 3. Well, look at these
That's a
first.
lot.
Look at these carbons. We gotta deal with the carbons, right? So if we deal with the carbons, we're gonna find that we're gonna add 1. And remember, if it's gonna be a coefficient, you have to change the whole molecule. So now we've started with 4, we've got 2. Let's see, that's 3, that's 4. All right, good. So here's our 3, 4, and 4. That looks good. All right, but here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 4, 6, 8, 10, 12. That's looking good. The hydrogen looks good, but how about the oxygen? 2, 4, 6, 8, 10, 12, 14. What do we have here? We have 2. So we need, oh, sorry, we forgot to put a 4. I gotta put it here. We're gonna need 1, 2, 3, 4, 5, 6, because that's gonna give us 2, 4, 6, 8, 10, 12, 14, which is what we need, because we have 2, 4, 6, 8, 10, 12, 14, which this is gonna be 7 pairs, right? 6 and 1, 7 pairs. And they're balanced.
There you go. You did it.
Now, this one. We don't have a marshmallow for. You can use marshmallows, or you can just kind of watch the numbers on.
You can choose whether you want to do marshmallows or numbers.
And here you have 1 sulfur and 2 hydrogen. Here you have 2 silvers, 1 sulfur, and then 2 hydrogen. So start with your silver. 1 here, 2 there. Well, we have to change that. And then we have to change that. So next you have your sulfur, 1, 1, okay. Hydrogen, 2, 2. Looking pretty good. And we're balanced.
Easy peasy.
We'll do 1 more.
So we'll come out of this one. All right, so I want to make sure you see. Hang on. Whoop, go back. So these are your Unit 5 test study topics. So you have a Unit 5 test coming up this week, right? You're going to do physical versus chemical changes, reactants and products. Remember, reactants undergo the change and the products are what they produce, right? Then endothermic versus exothermic. Go back and look at that. Be sure you understand it. Subscripts and coefficients. What's the law of conservation of mass tell us?
Matter cannot be created or destroyed.
Mass is never created. Yeah. So there's law of conservation of mass, matter, energy. They're all basically the same. It's cannot be created or destroyed, only changes form or only whatever in this time.
What about the
This
lost
situation.
contribution of gravity?
Not quite something we're worrying about. Not really. I think if you wish to, you may, or you can put them up. I'll give you a second to kind of clean up. And then y'all saw this, I think. This website right here. Okay, there's a QR for it if you want to scan it, but it's also part of, I think it was in your binder. And I think it was in it may be in a homework assignment too. It's somewhere. And it's also going to be in your weekly email and in your resources. Okay.
Yeah.
This is a great practice. You can go here and you can practice so that you're sure you know what you're doing as far as balancing equations goes. All right, so I'll give you guys just a minute to kind of pack up so we can get situated for
The
lab.
mnemonic is lab 11.
Yes, the mnemonic device, by the way, if you didn't turn in your mnemonic device, which is something for metals, non-metals, hydrogen and oxygen. Lucy, I think that's really yours, right? Metals, non-metals, hydrogen, oxygen. You have a mnemonic device. Be sure that you write that down, turn it in. Emerson, I got yours by email. So I know you're good. Be sure you have that and get it turned in. Okay, so put your marshmallows away, either like zip them up, put them in your bag. So we can be ready for lab here.
Well, how much do we got on our lab?
Lab 11 was
How did you do it?
it was a complete, no, we had to skip it, which is fine. Instead, you did the practicing balancing equations, which is fine. But it's a complete or incomplete grade. So the way those work, guys, when you see the complete or incomplete, oh, come here. When you see the complete or incomplete for a grade, basically if it helps you to have them complete. It doesn't ding your average if it's incomplete, but it doesn't help you either. And you want it to help you. Do what now?
Class 13.
Yes,
right?
we're about to do 13. Yes.
Well, it doesn't taste like lemon, so.
Yeah, they do. They're flavored. They taste like lemon. All right, let me end this. Does not want to come on. I'm clicking at you. There you go. Close.